I'm Curtis Hicks with Uneeda. Welcome to AWFS. I think it's going to be a great show this year, and we do appreciate you setting in on our 1 hour session here on sanding, because I know everybody loves to sand and learn about coated abrasives. So for those of you who don't know us, we're Uneeda Enterprises, and we manufacture sandpaper. Coated abrasives is the fancy term for it. And we're out of Spring Valley, New York. We've been around since 1967. We focus on woodworking. We make everything you can imagine: wide belts, narrow belts, discs, sheets, sponges, and rolls, and sanders. And what we're going to do today is I'm going to do a little bit of Abrasives 101, just to give you an idea of how it's manufactured, the types of grains you should be using. I'm doing the first half. The exciting part will be when Sherry gets up here and she covers hand sanding, and that's really what a lot of people like about this presentation, is to learn tips on hand sanding more so than me talking about belting. There's two things to really keep in mind about coated abrasives or sandpaper. Number one, all that sandpaper is a cutting tool. It's no different than, we have a picture of a pair of scissors here. That could be a router bit, it could be a planer blade. It's just a cutting tool. We're taking hundreds and thousands of little knives and we're putting them on a backing to create a tool for you to put on your machine to cut wood or MDF or any other substrate. The next biggest thing to remember about sanding is heat is the biggest enemy. It's the kryptonite to Superman is heat to sandpaper. Anything you can do to reduce the heat really helps extend the life of your sandpaper, and it really helps keep your finish where you want it to be. And we're going to talk a lot about heat during the presentation. So keep that in mind. The two biggest things: you have a cutting tool and you want to reduce heat. So in the old days when they made sandpaper, it was literally like taking a salt shaker and just shaking it onto a backing with some glue on it. That's changed a lot over the years, and it really revolutionized sanding when they came out with electrostatic coating. So this is what it used to look like. They would sprinkle it out, and as you can see here, your tips are all over the place. You got some sitting sideways, some pointing up, some pointing down. With electrostatic coating, they add a electric charge, and what that does is as the manufacturing process is going through, it causes all of these grains to flip. The heavy end goes up and it sticks to the backing. So what that leaves you with are very, very sharp cutting tools, because remember, these are just cutting tools. You want to cut with a sharp cutting tool, not a dull one. So that process really revolutionized sanding. Most everybody now that manufactures sandpaper uses electrostatic coating. That was really the very first big innovation in sanding. This is just a quick view of how sandpaper is made. You got a backing material. It's either going to be cloth, paper, could be plastic. Film's very popular these days. So it's just a substrate that you're going to coat to. You put on the first binder. Back in the old days, they used to use animal glue. They don't do that anymore. Everything's a resin. So you put your first coat down. It's called a maker coat, because you're going to put the initial grain down on that. It's going to hold it. Then you're going to put your second binder, which is going to be a second coat of resin that goes on the top, and that's what holds it in place. So this one's called the maker coat, and this part of resin is called the sizer coat, because you're sizing it and holding it down. After that, you can do a lot of things. If you're using disc, you may have a disc that's got kind of a white film on it. That's a filler. So they're putting that in there. It's a steration to make your stuff run cooler and not to load up. In the metalworking industry, we may come back and put an active filler to reduce heat in metal grinding. So lots of different things can go on that active filler. Sometimes there's not a filler at all. You know, it's just a regular coated abrasive with no type of additives to it. This is just a really cool picture. This is right from our maker. That's exactly what it looks like. You got a little glass you can look in, and you're literally seeing these grains just shooting up onto the backing. This is probably the most important thing that I'll talk about today, is friability. It's a fancy word to say that something cracks and resharpens. Because what are we trying to do? We're trying to create a very sharp cutting tool. And the way that sandpaper is manufactured these days, it's all done in a lab. It's very rare you'll run into garnet or any mined grains anymore. Still a little bit of garnet, but not a lot. Everything's done in a lab so we can make these grains do what we want them to do. And we focus on different substrates in order to develop the grain to do what we want it to do. Friability simply means that every grain starts out sharp because of the way it's coated. It's flipping up, you got the sharp grain down. Once you engage that grain and it starts cutting, one of two things are going to happen. It's either going to dull, and forgive me for the artwork here, I'm not the greatest artist, but it gives you the idea. It's either going to dull and lose that sharp tip, or it's going to crack and resharpen and create two new tips. That's called friability. So cracking and resharpening and leaving you with a very sharp cutting tool. And why does it matter? It's very important because you'll get this. This is a literal picture from two pieces of wood that we magnetized 40 times. This was using a very, very sharp grain, and you notice it just sliced everything open. Because on wood, just keep in mind, you're trying to open the grain so that you can get a good stain or good paint coverage on it. So this one was using a much duller grain, and what's happening here, it is shaving some of it, but it's also laying a lot of it down. And wherever you see this, when you go to finish, that's where you're seeing your blotchiness in your wood and stuff. And on maple, a lot of people, well, maple's blotchy, but a lot of times it's really coming from your sanding. It's a very difficult wood to sand, so you need something very, very sharp. This is more like plowing a field, if you can picture that. You're laying some of the grain back down, you're shaving some, but the grain that gets laid back down, what's going to happen when you put some finish to it? It's going to pop right back up, and you're going to have a lot of fuzziness that you're going to have to clean up, and you're going to have differences, colors in your finish. You're going to have, these are going to tend to be a lot lighter than these. Now we're talking about cutting tools. This aluminum oxide is one of the cutting tools that we're coating onto backings. Everybody in the industry, any industry there is, this is the #1 used grain is aluminum oxide, by far. In metal, wood, you name it, it's the #1 used grain. But as you can see, because we're doing all this in a lab, you can develop what you want. This is the most common grain right here, brown aluminum oxide. And it's very common because most abrasive manufacturers can use this grain. It works fine on wood, but it works really well on metal. It's going to tend to dull. Once that tip cracks, you're not getting that resharpening, you're getting a dulling effect, but that works really well on metal. Gives it a lot of longevity. But on wood, you don't want that. We don't want to crush the wood. So when we get into the finer grits, you're going to get into pink and white aluminum oxide. They're very, very pure grains. So what's happening under light pressure, just from the wide belt machine or from your hand pushing it down, it's going to crack and resharpen. The white is the most friable, the pink is in the middle, and it's very critical when we manufacture. We want to have those kind of grains on your finishing grits more than anything. It's not so much on your stock removals. If you're plowing through that a little bit, it's okay. You just want something very durable. But for your finish, you really want light pressure, and you want that grain cracking and resharpening. So whoever you're buying your products from, it's good to have that conversation maybe with your sales rep. Say, hey, what kind of grains are we using? You know, maybe they can educate you a bit on what they're doing. There are a lot of good manufacturers out there of sandpaper, and a lot of them are using these grains for their final finish on wood. But that is the #1 used grain. Brown is by far the most common, and then when you get into fine finishing and on your last few heads of the wide belt, you want to get to the pink and white aluminum oxide. Silicon carbide is a very, very popular grain in our industry too. It's a very unique grain in that it's extremely hard. I mean very hard, but it's extremely brittle, which means it cracks really easy. And people are like, why would you want to use silicon carbide then? But if you're sanding in between coats of finish, the last thing in the world you want to do is cut through it, especially on sealer. And stains coming back, thank God. You know, not everything's painted anymore. So on paint, it's not as bad to cut through. On seal coats, you just don't want to do that. So a lot of people go to silicon carbide on the final heads. A lot of hand sanding in your finish shops are silicon carbide because that grain's cracking, resharpening, and you're not cutting through your finish. And also on wide belting, we really, a lot of times, try to coach our customers to go to silicon carbide on the very last head of your wide belt sander, because if you're having to sand cross grain, if you're making a 5-piece door and you don't want cross grain, you got to come back and sand that out. And if you use silicon carbide and lighten that scratch up, it's not going to be invisible, but it's going to make it a lot less time for you to have to sand that cross grain out. It just kind of melts away if you leave that really, really soft finish that silicon carbide will do. I am going to mention a couple of other grains because they are used in the industry. Ceramic aluminum is a very unique product. It's not made the way other grains are made. We do see some of this in wood. Our particular philosophies is we're not crazy about ceramics on wood. It was really designed for titanium and stainless. Now that grain is friable. It does crack and resharpen, but you have to keep in mind if you want something to crack and resharpen, the substrate that you're hitting needs to be harder than the grain to crack it. Unfortunately, a lot of times ceramic is stronger than the wood. And so I go into shops and they like ceramic because it lasts a long time, but a lot of times I'll look at the shelf and say, man, the shame is you've got a lot of life left on this belt that you're never going to get because you can't crack that grain and get it to resharpen. And what happens, they start glazing over their finish. Heavy stock removal, it's very good. And there are certainly companies in our industry that are selling it into finishing and everything else. And our philosophy is just a little bit different on that. Zirconia is a great product. It was designed for stainless, but this is really good on abrasive planing. If you're doing glued up to make insert panels and things like that, so you got real thick differences and heavy glue and really big steps in between your glued up parts, this is a really good product just to hog it down. So maybe on your 36 grit, 40, 50, 60, 80, somewhere around there is your first initial calibration head. That's a good product to use sometimes, especially on harder woods like hickory and maple. So you will see some zirconia in the industry. I know this is kind of a comical thing from our plant in Sweden, but it does give you a quick picture of what happens. This is how sandpaper is made. It starts with a roll up here at the top, you print it, you put the first coat on, which is called the maker coat, and then you go to the very special process of electrostatic coating, lots of inspecting, and then when you come here, and then a lot of heating. If you saw a maker, it's very long because this stuff has to run over several rollers for a long distance to really bake that grain onto the sandpaper. And then after the drying, you have another quality control. This will be your second coat of resin. That's your sizer coat that holds everything down. More inspection and tons of drying, and then we wind it up and send it out. Grit charts, the only reason I brought this up is just so you're aware, most everything you're going to run into in sandpaper is P graded. That's a European grading system, so if you look at the back of your sandpaper, it's going to say P120 or P150 or P180, and that's very important to know because if somebody were to use, say, a CAMI graded system, which is a very old grading system, if you're trying to do a 400 grit, for instance, in a regular P grade, look at the difference in that. This is going to be a lot finer on the CAMI graded. But where this chart will really come in handy is if you're using a lot of micron graded products. There are some companies that prefer to grade by microns. It's kind of similar to the difference between inches and millimeters. But this is a nice chart because, for instance, we don't run into a lot of orbital paper where they want a 150 grit, and a lot of the micron being used is 100. So we just have to kind of run our finger across and say, okay, that's a 150. But just don't get caught up in your mind that, oh, it's got to be a micron, because like I said, it's just a grading system. It's like comparing an inch to a millimeter, and 90% of your paper is going to be P graded. It's the most consistent grading system. Paper backings, just a real quick thing on this. Your lightweight papers, your disc, sheet paper, that's always going to typically be an A or B weight, at the most a C. So these are all, just keep in mind, hand sanding items, A, B, and C weight papers. E and F weight is when you get into wide belting or stroke sanders where you need a thicker material because you're putting a lot of pressure on it. Like you're going to put 100 pounds of pressure or 40 or 50 from the wide belt sander, you need that thicker paper. So if you're using paper in your shop, you're most likely using an F weight. We really don't even get into E weight papers till we get into much finer grits like 320, 400 and above when you're doing sanding in between coats of finish. Cloth starts out at the bottom with extremely flexible cloth. Back in the days of furniture, when some was made here, there used to be a lot of moldings, and you'd really need that paper, the cloth to conform into that profile. That's what a J weight will do. This one's JF is extremely flexible. You just take it and just, it's very pliable in your hand. It goes all the way through the system till you get to a YY cloth. That's extremely heavy and durable. It's great for really rough applications like floor manufacturing, for instance. On the first heads in there, you've got little sticks coming through that are poking out and hitting the belts. This will actually, the Y weight is very durable for that. The most common in the industry is going to be X and XY. That's for woodworking. That's just the most common cloth material. So J-Flex is the most flexible, YY will be the stiffest and most aggressive backing. And by the way, these are washable as well as XY. We don't run into that as much as the old days when people did pine and poplar and stuff like that. Then you really want to wash belts. These days, most people are doing hardwoods. Not a whole lot of reason to wash the belt. By the time it's loaded up, it's usually pretty worn out. But if you do need to wash belts, you need an XY or YY weight backing. Flexing is very important. The way you get that really, really flexible cloth material is once the jumbo roll is made, and these are made in big, giant, 100 meter, 200 meter rolls, they take them and run them across bars at 90-degree angles. So it depends on how much you want it flexed. If you want it very flexible, you're going to flex it several times. Even the stiffest, heaviest cloth material in the world has been flexed. You have to flex it a little bit or the resins will crack. So if you try to put on a Y belt and it wasn't flexed, it's going to crack when you try to run it around that Eiler roller. So no matter how stiff it is, it has been flexed to some degree. Types of coatings, closed coat, open coat, extra open coat. Back in the day, again, when I started this 30 years ago, lots of pine and poplar, extra open coat was very popular. Because all that simply means you got more distance between the grains for what you're sanding to load up before it reaches the height of the tips of your grain. Not such a big issue anymore because most people aren't doing wood species that are going to load up. I would say the most popular coating these days is kind of a semi-open. It's kind of between open and closed. Now when you get into your final finishing, like I was mentioning, maybe silicon carbide on your last head and a 180 or 220, you want that to be as closed as possible. And the reason is you're bringing those scratches much closer together and it's going to blend in easier on your cross grain, and so that you can't see it as well as you would if you had a very open coat material. We do get this question a lot. It's very subjective. What we call open coat, another manufacturer may say is semi, but for the most part, that's what the differences are. And these days, you don't need to be nearly as concerned about the openness of the coat as we used to be in the old days. Consistent grain height is very critical. This isn't the best graphic. I had a hard time finding something. But what tends to happen here, if you see here, all these grains are the same height. And on this picture, you got some grains that are taller, shorter than others. It usually comes from the cleaning of the maker. So if we were running 150 grit grain and we didn't clean the maker well when we switched to 220, you might end up with some 150s mixed in with the 220. And until that 150, that taller grain breaks down to be even, you're going to get what we would call wild grain scratches. So I tried to show it, but a lot of times if you look in your finish, you'll get every now and again you'll see a really dark scratch. That's usually coming because you got kind of a wild grain in there that's a little taller than the others. So it's very important for your abrasive manufacturer to really do a good job of getting those grain heights the same. It reduces your break-in period till you hit that sweet spot on the finish that you're looking for. Never skip more than one grit. I bet you've all heard this a gazillion times. Now we have customers, and I'm just going to say it, if they've got a two-head machine and they don't want to change that machine 3 or 4 times, we certainly see people skip a few grits and get away with it and get the finish they're looking for. But the philosophy behind it and the reason that everybody in this industry suggests you don't skip more than one grit is in this case we're going from 80 to 180. And what's happening when you sand, you're creating peaks and valleys. And what you're trying to do on that next grain is get as close to this valley as you can, because in this situation with an 80 and a 180, this is going to bleed right through. When you go to finish, you're not going to get that 180 grit scratch. If you were to run it like run a board this way and then run a board that way and put a scratch in, it'll look like a checkerboard, because you're going to have that 180 grit scratch really bleeding through, and that's going to show up in your finish. Now, when you only skip one grit, in this case 80 to 120, you're getting much closer to this valley here. And it's close enough that it's going to hide that 80 grit scratch. It's not going to bleed through. So in our opinion, it's very important to not skip a grit, and that goes for hand sanding, especially wide belt sanding, because wide belt sanding has a lot of pressure. But again, we realize the reality is what it is. And we do see people that are very successful even skipping a few grits if that's, if they just don't have the equipment to be able to quickly change out and not skip any grits. But really try to avoid it if you can. It's going to definitely help your finish if you follow this rule. Anti-static, boy, after electrostatic coating, this changed the world here for sanding. Doesn't really affect cloth as much as paper, but when you're sanding, all you're doing is creating friction, and you're creating a bunch of static electricity. That's what's happened here. Before this was patented back in the 70s. Dust was just everywhere. I'll go into a shop right now and you can tell when they don't have good anti-static properties because dust is sticking to everything. What anti-static properties does, it's actually an additive into the belt, either on the back or in the face. The best way to think about it, it's kind of like a graphite, but what it's doing, it's repelling that charge. So it's pushing, whereas all the dust wants to stick to your part, when you add a static charge, it's pushing that dust away towards your dust collection system. It's very rare you'll find a paper belt anymore that's not anti-static. It's just a very common thing these days, but that really revolutionized sanding. It's really the latest big thing that came out in sanding, and that's been many, many years now. Belt tensions are everything. We're talking about trying to reduce heat. Anything to reduce heat. When you're sanding with a DA sander, and I'm as guilty as anybody else, I go home and do sheetrock. I'm wanting to push hard and get done quick. It's the worst thing you can ever do. The weight of this machine is enough to make that grain crack and resharpen. Pushing on it, yeah, you feel like you're cutting more, but really what you're doing is you're driving that grain down deeper than you should. You're creating swirl marks. Let the weight of the sander do the work. On your wide belt machines, you want to run under as little belt tension as you possibly can, because it's going to help your abrasive last longer. If you had that belt so tight that you can't squeeze it, it's a big impact right when it hits that wood, and it's going to tend to wear your grains out a lot quicker. What you can see our tech doing here is reaching in, he's just simply pulling that belt apart to see if that eyeler head will move. You want that roller to move really easily, because first of all, if you got it so tight that it won't move, you're going to start killing your bearings. And secondly, it's really much harder on your finish. So belt tension, low pressure, everything you want to do about sanding is as little pressure as you possibly can to reduce the heat. Everything's about reducing that heat. Maximum stock removal. Sanding is just math, especially wide belt sanding. It is just math. If you've got a part that's 780 and you want to get it down to 750, you got to take 30 thousandths. And you know how many heads you have to do that with. So for instance, if I'm running 25 feet a minute at 80 feet a minute, the maximum I can take off is 25 thousandths. I can push that grain down and take 40, and what you're doing is you're driving a grain that long, that deep. You're going to start burning wood, you're going to wear your product out much quicker, and your finish is going to suffer. So grit chart removal is extremely important. If you guys want a copy of that, let us know. We can send it to you on a magnet. You can stick it right on your machine. I would have everybody in my shop to understand the importance of grit sequence compared to feed speed. It's all about the feed speed, because the slower the machine runs, the more times that grain's going to come around and impact the wood. That's the same thing in millimeters. Wide belt setup, got about 7 minutes for you. So these are tools we use. These are tools I really recommend you get if you do a lot of wide belt sanding. Obviously everybody has calipers. Test the stock removal rates. What we typically do that you can do in your shop pretty quick is run a head, one head at a time test. So if you have a 3-head machine, you want to put a stick in both sides, run the first head and measure it. It's going to tell you if your machine is out of level. It's going to tell you how much stock removal you have. If you got 10,000 stock removal on one side and 3 on the other, you're going to have to get that head leveled up. And that's what we're doing with this board here. Now there's also a way to do this called a storyboard, where you can run a long piece of MDF. It needs to cover the whole length of your machine. Put one on both sides, turn it on, hit that emergency stop. And then you'll see the layout of your heads right on that board. You can measure it, and that quickly will tell you if you're heavy left or right, if you're level. This takes a little longer. We don't love hitting the emergency stop on a machine, but if you need to do it quick, do it. And we do that sometimes when we're in a hurry. We have an airflow meter. That's not something you need to invest in. And quite frankly, I hate when our tech uses it and tells somebody that their airflow is not good, because what are they going to do about it? You know, you're going to go spend a couple $100 or something to fix it. But we do have the meters for that. If you can get one, it's great to have. Static is very critical in sanding, and people don't realize it. Sometimes they even have it. So static meters are good. It should basically read 0. If you see a high static charge, there are things you can do to help reduce it. Digital indicators are very nice if you really getting your heads level, you can do it with sticks, and people do a good job of that. What we tend to find is people don't address their hold down rollers and their shoes as well as they should because they don't have the equipment to measure it. And if your hold down rollers, for instance, are too high, you're going to get sniping and all kinds of other issues out of your sanding. Common issues, chatter. Everybody's seen chatter. Chatter either comes from a machine or it comes from your wide belt. And the easiest way to figure that out is if it's coming from the wide belt, if you turn your feed speed down so the machine is running slower, then that chatter is going to get tighter because the joint's coming around and hitting it more often. If you speed the machine up, the chatter will spread out. If you do either of those and the chatter doesn't move, that's coming from a machine. Something's just sitting there constantly vibrating, and it's usually a bearing. But a lot of times chatter is from a belt. Everybody makes mistakes. You put a joint too thick on there, it's going to cause it to bounce. And chatter comes from something bouncing. Raised lines are usually pins. If you're hitting pins, you've pretty much killed the belt. You're either going to have raised lines, you'll have to sand them out. Best thing to do is change the belt. Dips are very common. Unfortunately, I didn't have a picture. This is usually when your parts are getting caught in your machine. And that's most of the time because your conveyor is probably very slick. And a cheaper way to kind of help fix that is you can take simple green and coat your bed and with a nice soft bristle brush, let it set over the weekend. It doesn't hurt the rubber, and it will help that rubber stick better. Static. It always looks like this where it's a jumping line. People are like, I don't even know what this is. That's coming because you're getting too much static in your machine, and it usually happens when you see big weather changes, especially when it gets dry and cool. That's when you'll see static. And the best way to fix static is to ground your machine and ground it correctly. Everybody says, oh, my machine's ground through the wiring. That's fine, but that's not grounding it the way it needs to be grounded. In this picture, they did it wrong because this is on a plate on the machine. You want to ground it directly to the bed of the machine, closest to the end, your last head, whether it's a platen or drum. This will help a lot to take static away. The thickest wire you can put and try to drive you need to drive a grinding rod, especially you really want to use copper if you can, although like rebar is okay, but copper's better. And you want to get through the fill dirt. You'll be amazed at how much this helps your dust collection work better by grounding the machine correctly. Just real quick on the joints, these are called butt joints. And the reason it's called a butt joint is because you butt the two ends together and you put a piece of tape on it. You will skive out and create like a little channel for that to set in so that you can get a zero tolerance so you don't get the chatter. This particular tape, if it were on the last head, you would probably get chatter because it's thick. We're not worried about it because that's a calibration joint. So we're just leveling, and then later on we're going to switch to this joint, which is much thinner. This is the most common joint in the business, and I'll tell you the reason why it's the best joint in my opinion is because you don't have to think about putting that belt on. Either direction, the arrows mean nothing on the belt because it has a butt joint. The reason that we print arrows on the backing is we don't know what kind of joint somebody's going to make out of it. And if this were a lap joint, which looks like these, then it's very important that you go the direction of the arrows because of the way this has been lapped over this piece. If it goes the wrong way, it's going to catch right there and pull it off. So the most common is tape. Lap is very old school, but some people still prefer it. And one thing I do want to say is we get a lot of people that ask for this joint, this squiggly joint. There's a lot of, in my opinion, misinformation out there about it. They think it helps with chatter. So I'll see somebody with a squiggly joint, and I'm like, okay, was your chatter squiggly? They're like, well, no. I'm like, that's, the chatter's coming from the tape, and that's flat. A lot of companies can make that joint, but don't buy into it too much. It's not that critical to have a finger joint. In fact, to me, it gives more room for error, because if those little fingers happen to kick up or something, it's going to catch. This particular joint we use heavily on double end or sand and shape machines like Marine Johnson's. It's such a harsh application. We actually cut all the grain off the top and we put the tape on top. So this gives you a perfectly zero tolerance right here. We also do it a lot in the flooring industry when they're using metal drums, because it helps take out the chatter. Because metal's going to chatter a little bit no matter what you do. You're getting a little bit of bouncing. And belt storage is critical. On paper belts, don't ever do this. Cloth, not so bad. Paper will suck up water like a sponge. You put it on concrete, this side's going to be bigger than this side, and you're going to have a hell of a time getting it to track until that water dissipates out. Try to hang your belts if you can, and more importantly, if you can, put a piece of PVC in the bottom, 3 or 4 inch. It's going to match your eyeler roller. It's going to make that belt so much easier to put on. But if nothing else, try to get these off the floor or put something down, like some cardboard or something. You really don't want to set paper belts on the floor. And if you really want to spend some money, this is the most awesome thing ever, to have a dehumidifier in a nice little room there. Yeah. So that's great, especially in areas that have a lot of humidity. Like in the south, you'll see belts really cupping. It gets so humid because it's soaking up water. So belt storage is very important. Last thing I'll show you before Sherry starts is don't ever throw a belt away because you've torn the edge. We see this all the time, and people are just throwing money away. If you get a little tear, and usually it's from putting the belt on your storage rack, it could be when you're trying to put the belt on the machine, it's easy to tear it. But you don't need to throw it away. You just got to cut a half moon from behind that tear. Cut that half moon out, and you can run that belt all day long. I've seen half moons cut this wide before because people were only using one side of their machine to run all day long. You don't have to worry about it. The eye will read it. It's turning fast enough. But don't ever throw belts out because you have a little bit of a tear in the paper joint. We also make these on placards with a magnet, so you can stick that on your machine, because that's another good thing to have on there if you've got people working in your shop that's not, understanding sanding so well. That's my part of it. Now the exciting part, Sherry's going to teach you about hand sanding after she broke her wrist.
I'm not using anything motorized?
No. It's gonna be both with the machine and without. With the orbital sander, and I know everybody's gonna go, oh wait, what about the square sanders? Aren't they jitterbugs? No, most square sanders are orbitals now. So we'll talk a little bit about it, but it'll be a combination, right? Why do we hand sand? So, when you wide belt, everything comes through, it's linear scratched. If you don't have any rails or stiles, if it's not a door, if you don't have, or it's not a face frame, and you don't have any cross grain, I don't recommend sanding. I don't recommend taking that nice, pretty linear scratch and making a big mess with swirls, right? But unfortunately, we do have doors, we have face frames, and we have other areas where we do have to sand out that cross grain, and it's important to know how to do it and how much sanding we should be doing. A lot of times now with cross grain, I see a lot of people that end up over sanding, and they actually put more swirls in than they really need to, because there's a breakthrough period with swirls. Once you start swirling, you can't stop it. Unfortunately, it just continues to it's like a domino effect. You see one swirl, and then you start looking, and you've got them all the way down the wood. So my job is to tell you when to stop, how to stop, and how to fix it if you do end up with swirls. Proper hand sanding techniques, we'll go over that a little bit, and that's just with the machines. That's going back to the random orbitals. Random orbital sanders, even the square sanders now, they're not random, but they are a 3mm direct drive, right? So even though in the past we had the little jitterbugs that would just they were just up and down, they were just back and forth. Now with the square sanders, we've got that orbital pattern going, and so these are more indicative to swirling than your 5-inch if used properly. Even if the best sand in the world with the 3x4 is probably going to get sanding swirls, just because of the fact that it's a direct drive system. When it's a direct drive system, there's no other pattern to take that swirl out. So I tell people all the time, I have a lot of people that drop in a center panel on a door, and then they'll use a coated abrasive, and they'll come to them and they'll say, well, it's all swirled up, it doesn't work. And I say, well, it does work in a sense, because it allows me to go corner to corner and sand out any imperfections like drag marks or anything like that. But then the problem is it does leave swirls. So what we came up with the 3x4 is that if you have a 3x4 and you use it in a center panel, you've got a bunch of swirl marks, we'll use it's like a Scotch-Brite type material. Either the maroon or the gray, depending on how much swirls you have and how deep they are. But you'll either use a maroon or a gray, and you'll run that on your 3x4, and that'll actually take out the swirl marks. It'll mask them. So I can actually stain over that now and not see the swirl marks in the wood. So pneumatic sanders. So there's a lot of sanders out there on the market, pneumatic and electric now, and we're seeing more and more people come out with different sizes, different hole patterns and all that. We try to match them as best we can, but these are the basic sanders that we see today. So we got a 3-inch, and if you've ever done bowls in solid surface, that 3-inch is a game changer. The 3-inch allows me to get from, when I drop inside the bowl, it hits the whole face of the sander, where the 5-inch I'm only catching about maybe an inch or a quarter, or 3/4 of an inch on either side of the pad, so I don't get a good blend. With the 3-inch sander, 3-inch pneumatic sander, now I can get the whole face of the bowl when I drop in, and it'll cover that whole face of that sander, right? So the next one is the 5-inch and the 6-inch. These two are our workhorses. That's where I see it on the hand sanding table. After it comes off the wide belt, you'll always have a hand sanding table with people standing around there, either running a 5-inch or a 6-inch. If you're still doing some stock removal, if you still got, a lot of cross grain, what I tell people all the time is that you're going to go to 3/16 because we're still wanting to hog a little bit of wood off. The 3/32 is more for finishing, so I'm going to use that in the finish area. But the 3/16, and these are the 5 or 6-inch, is where I'm going for my raw wood sanding, or white wood sanding, however you want to call it. So if I'm going to remove cross grain, it's going to be a 3/16. If I'm in the finish room, I'm going 3/32 because I want to finish. If I'm on solid surface, again, I talk a lot about solid surface. I used to not think that the market was going to survive once granite and all the rest of the products started coming out, but there's still a lot of solid surface in the market. So when I sell to solid surface, it's always a 3/32 because I want that tight orbit. The 3/16 has a much broader orbit. You'll see the swing of the backup pad is much wider, so it's a much larger swath, where the 3/32 is much tighter, so I can get a finer finish right there. Then you got the 3 2/3 by 7 and the 3 by 4. The 3 2/3 7 is nice in the sense that that one is a random orbit pattern, where the 3 by 4 is just the direct drive. This one actually does have a random pattern to it. So if you've got like large cabinet doors, really big, the bigger like for pantries and such like that, those are really nice because I still can get in and go corner to corner with them, and yet I don't get the swirl marks I do with a 3 by 4, and I've got a larger footprint, so it doesn't take me as long. That's the biggest drawback of the 3 by 4 is the footprint is so small. It's great for small doors, it's great for shaker doors, but when you start talking about large panels, using a 3 by 4, it takes forever because it's such a small footprint. And I tell people all the time, there's no reason to run the 3 by 4, even if you run in a foam abrasive. We make foam abrasives now for the 5-inch, the 6-inch, the 3 2/3 by 7, so you can get a foam abrasive on a random orbital sander that's going to give you that same, but it's going to give you the bigger footprint and the much quicker sanding. These sanders they're very durable, right? 3.2 cubic feet of air. They do require a lot of air. I have a small compressor at my house. It's like 21 gallons. I can't push them. So it does require quite a bit of air. 3.2 cubic feet per minute. And it's, lost my train of thought right there. I was going to the next thing and I lost my train of thought. But these are very durable. They're much more durable than the box store sanders that you're going to buy. And you're going to see that too with the electric sanders. They're designed for industrial use. They're designed to be in cabinet shops. They're designed to be in factories. They're much more durable. The biggest thing with air sanders is maintenance. I see a lot of times I'll go in. The two biggest things that I see on air sanders that we have problems with is the filter cap. I have a lot of people that'll take that off because they're like, oh, I want more RPMs. Okay, you'll get more RPMs, but the filter cap is what protects the bearings. Because if you pull the filter cap off and you sand, and then you release the lever, anything you sanded, all that dust just goes right in the sander because it becomes a vacuum. This is, right now it's pushing air out when you press the lever, but when you release the lever, it becomes a vacuum, so it sucks everything into the bearings. And then your bearings go out very quickly. The other thing is that if it's spinning faster than what the sander is designed to go, you're putting a lot of strain on the motor, and that wears your motor out much quicker. So the filter cap is it's very, very, very important. The other thing that I've heard several people have said, well, my manufacturer said I didn't need to worry about oiling my sander. Curtis made a point, heat. Heat is what drives everything, right? So heat causes friction. All these parts moving, friction causes heat. All these parts moving inside the sander, it's just heating it up. If there's no oil to keep that friction from happening, everything starts to wear down, and the sander eventually, the phenolic veins in the housing will lock up, and the sander's done. It's not very easy to change out the motor and such in these sanders. You have to have certain tools and all that. It is possible, but sometimes especially if they're not oiled, it's really not beneficial, because by the time you bought all the parts, you just soon buy a new sander. So oiling it will help to maintain your sanders much longer. Electric sanders. Electric sanders have come a long way. We have a lot of competitors on the market. Festool makes a great sander. The biggest disadvantage is the height. It's kind of like a box store sander. These sanders are designed to, a lot of people have them out now. They have the paddle-driven system. You'll see it up at the top. So it operates more like a pneumatic sander, right? Which is much friendlier to use, because one, I like for my hand to be close to the part. I like to be intimate with the part I'm sanding. I can feel, I don't know if I'm the only one, but I can feel when I'm sanding, I can feel if I have like areas that are raised up or uneven, or if I've dug a little bit, I can tell that. And so being closer to the wood is important. And so these sanders sit low profile. They have a much lower profile. The other thing is they're all now, most electric sanders are brushless. That's huge. That's the first thing to go out in an electric sander is the brushes, almost every time. You wear those brushes out, they're done. The sander is gone. The other thing is these are DC driven. They're much longer lasting life. So when you plug into the wall now, the life expectancy, because they're a direct current sander, is much longer. So it's a much better setup. Electric sanders have come a long way, and they still have, some issues, but the biggest thing is that now that the life of the sander is much better. And if you're in a situation where you don't have a big compressor, where you can't run a big compressor, these are a great option. Advantage of square sanders. So, and I know this is a little bit to be about rough to ready, so we'll get into some of the abrasives here in a minute, but I just wanted to go through all the sanders, the options. The reason, like I said earlier, is that the square sander gives us the ability to drop in drawer boxes, where formerly you would sand with a round sander, and then you still had to go back and sand by hand in the corners. Same thing with doors, same thing with any type of profile. It gives you the ability to be able to sand quickly and better. It gives us a more uniform sanding. The biggest drawback, like I said, is with a coated abrasive is that it does swirl. But we still have that ability to go corner to corner, right? The other thing is that sanding is always, especially the hand sanding part of in the finish room, is always the bottleneck. That's where everything stops. It's like it gets to the finish room, they put the first coat of primer on it, and then it's just like everything just goes to almost a crawl, because it takes so much time to hand sand everything. With these sanders, it's changed that. We've gotten probably 90% of the sanding by machine now, and it's only 10% that's done by hand. So now I'm able to push the product through the shop much quicker, which saves money for the cabinet guys because they're not, their labor cost has gone down, the amount of abrasives has gone down, and we're able to push it through much faster. We're not standing and spending so much time folding paper, trying to get in the little cracks and all that. We're able to do it with the 3x4. So coated abrasives, Curtis kind of went through the different grains. You see today, you see net, you see film, and you see paper. That's the three big coated abrasives that you see in hand sanding. I have done some testing with the net and with hole patterns and vacuum sanding, and that's a whole nother seminar by itself, and what my thought process is on that. But I tell people all the time, it depends on what you're sanding, where you go to with your coated abrasives. The net is something that came out several years ago. It was more designed for automotive sanding, not so much for woodworking. It was designed along the lines with a foam back abrasive for the nano coats on automotive that were scratch resistant. You know, if you bought a Mercedes or a BMW, they had a great coating on the outside. You can run your key down it and you couldn't scratch it. But if you wrecked it and you tried to finish it in a body shop, it was a lot different than finishing it in a manufacturer, in a factory. So what ended up happening is they came out with two designs, the net being one of them, and another one was a foam back abrasive that allowed you to be able to sand that, where a coated abrasive, a normal coated abrasive, either paper or a film, would not take any orange peel or dust exclusion out of that. It was, you know, you were in a situation where it was just like driving the key down it wouldn't take it out. So they designed those two, and they work great. And then we started to see them bleed over into the woodworking industry. And we have net abrasives, and it's a good product. Not saying that, but I don't see a lot of advantage, because the biggest advantage, what we're trying to do is shave wood. And the biggest advantage to shaving wood is having as many knives as we possibly can. So when you go back to a coated abrasive, you want as many knives on your disc as you can get. And I feel like the net just kind of cuts that down a bit. But the film and paper, it kind of depends on what you're doing, what you're sanding, and what type of wood type. Foam abrasives, that's been a big one. We talked about hand sanding, and you asked the question, would we just be doing just hand sanding by hand, or would we put it back on a machine? And this is one of the things that's come out in the industry, and it's changed. To me, it's been the one thing that has changed the finish from the most. Because these products are all designed to outlast a regular coated abrasive by exponentially longer time. And the reason being is because most of them are made with a stretchable latex face. And so as you're sanding, it's stretching, it's dissipating the dust away from you, and it's allowing your product to really continue to cut and keep itself clean. And the longevity of the abrasive drives the abrasive costs down, as well as you're not changing as often, right? So it comes in three forms. You can see a 5 mil, 10 mil, and a 1/2 inch for the sander. And those three different sizes, the 1/2 inch is designed specifically for profile sanding. So if you've got, you know, crown molding, that you got to do a ton of crown molding, you got to get in between there. Formerly, you were doing that all by hand. Now we've got a foam abrasive that you can put back on a machine that will conform to the profile of the crown molding, and you'll be able to sand that crown molding in much quicker time and finish out. The 5 millimeter is for flat surfaces, so is the 10. The 10 just allows us to get into square areas a little bit better, like shaker doors. Foam abrasives change, the grit equivalency now is different. So we don't have just a grit sequence. We don't say, oh, this is 180 grit or this is 220 grit. We have a grit range, and that's because the grain, the foam allows the grain to recede into it, and it allows it to cut at if more pressure you put, the heavier the grain the cut's going to be. So say like a fine is a 180 to 240. If I put some pressure on the sander, then I'm going to be closer to a 180. Whereas if I let the sander just sand, I'm going to be closer to a 240, right? So it's hard for us to tell you exactly where that scratch is going to be, but it's going to fall in that range, depending on who's sanding. Hand sponges. Block sponges were the rage years ago. I think when I first started 20 some odd years ago, block sponges were the only way to get into a square surface. And I still see a lot of people use block sponges because there is areas where, you know, either you're in a home, like you're repairing a home, you're in a work environment that you can't bring a sander and throw a bunch of dust. And the block sponges gives us that ability still to hold on to it. They're much easier to hold on to than the other two apparatus, but they're still, it's still, you know, a good final scratch. And you can follow the wood pattern, like the sanding pattern with the block sponge much easier than you can sometimes with using a sander, right? So you can follow, if you want to follow the scratch pattern, you can follow it much easier with the block sponge, where with you might have with the sander you may have that swirl marks and you want to take that out because you're working on stain. So the block sponge is still a good option. The 3/16 and the 1/2 inch. The 3/16 is one of those products that's, if you love it, you love it, and if you don't, you don't, because it's sometimes hard to conform to your hands. It's not as easy to close up. It's not as easy to maneuver, to manipulate, to get into areas. But they're still available, and they're a good product. They're a closed cell foam, so the grain is much more prominent on that than it would be with a 1/2 inch, because 1/2 inch is an open cell. But the difference between these two scratches is going to be because of this closed cell foam, because the grain's going to stand up more prominent, right? With the 1/2 inch, it's going to recede a lot more. It's a lot softer sponge. It's an open cell foam. You can actually see the openness of the sponge. And these are designed more for, you know, around the edges, if you're trying to come around the door edge, they're designed more for that, and it conforms more easily to your hand. So before we I'm not going to end right there because I know we want to talk from rough to ready. One of the things that I've been faced with a lot in the last couple of years is MDF. And I've had a lot of questions from people that says, how do you finish MDF? How do we get to, 1 prime or maybe 2 primes? And I really like to try to get it down to 1 prime before you go to paint. And the only way to do that is to burnish that MDF down. Everybody thinks wood when we talk about when we talk about opening a surface, because when we sand hardwoods, we sand to open the surface to accept either the paint, to let the paint lock in, or to accept the stain. With MDF, we want to think opposite. So we want to close that MDF back up like it was from the factory. There's only one way to do it, 320 grit. You can try with, if you go coarser, you're going to actually make the fiber stand up, and the minute you put any primer on it, the fiber is just going to stand straight up and look at you. And then you're going to have to sand. And then you're going to prime again, and then you're going to sand, and you may even have to prime again. I've been in companies in Canada that was priming 3 times, and they were just going through primer like crazy, and they were like, there's got to be a better way to do it. And I said, well, you've got to burnish it. You've got to close up that MDF so that primer, when it sits on top, it's sitting there, it's locking in, but it's sitting there, and it's a much better surface. And that way when I go to paint, I'm only priming once and I can go to paint. I'm just doing a light scuff, and I'm not raising those fibers again. On raw wood, it's the opposite. Like I said, we want to open the surface. When I talk to people, especially if they have a wide belt in their facility, that's where we want to set our color, is on the wide belt, right? So hand sanding, my job is to reduce the amount of hand sanding you're doing in your plant or in your facility. And to reduce it, we've got to get the wide belt working perfectly. And if you get a really nice scratch coming off the wide belt, I don't want people spending a lot of time sanding and sanding and sanding, because like I said in the beginning, random orbital sanders are great, but you're going to get swirls. And once you start to get swirls, you can't stop them. It's just going to continue to swirl. The more you sand, the more swirls you're going to get. So what we want to do is we want to find the happy medium. So if my cross grain is coming off at, like, say, a 180, I may have to go around the outside on the door. I may have to go around it 3 times, possibly 4, with a little bit of emphasis on the cross grain. But I'd never want to spend, 3 to 5 minutes sanding on that door, because I've put a nice linear scratch in it. I want to try to keep as much of that as I can and not have all the swirl marks. So I'm going around the door probably 3 to 4 times max, right? A lot of times with the center panels, if you're building your own doors and you run your center panels prior to assembly, then I tell people, don't sand the center panels. I still see people, their hand sanding tables, they'll do the rails and stiles, and then they'll drop in the center panel and they'll sand it. And I'm like, why'd you sand that? And they said, well, because it needs to go to finish. And I said, yeah, but you've got a nice linear scratch in it. Now you just put all these swirls in it. Everything that we worked so hard to fix for you coming off your wide belt, you've now messed up. So if your door is not something that you're buying out and it's not sitting and closing up, there's really no reason to sand the center panel. We shouldn't be touching the center panel. We should just be sanding the rails and stiles, right? Same concept on face frames. We shouldn't really be worrying about we should leave that linear scratch and just going over the areas where you have cross grain and spending as little time as possible just to remove it where you're not seeing it. In paint, it's not as crucial. You can see it sometimes if it's deep. If you're finishing at, say, a 150, you can see it. But if you're going to 180, 320, I tell a lot of people on face frames, I don't even recommend sanding it out, because you're going to fill it in with paint. So there's different things, tips and tricks of the trade that we've learned through the years, and the biggest thing is knowing when to stop hand sanding. And that's the minute you start to feel like there's the surface is getting slick, or your sander's changed in how it's going, you should immediately stop. And like I said, the 2 to 3 trips around the door frame is a general rule. You can look at it after 2 to 3, and 9 times out of 10 your cross grain's gone. Training your people to do that is huge. We do that all the time. It's just it's an improvement in your process. The other thing on hand sanding, the last thing I'll say, is lighting. I see a lot of tables that everything we want to light from the top up. And when we're hand sanding, a lot of times, almost always, it's the new people in the shop are thrown on the hand sanding table and they said, go sand out the cross grain, and you kind of explain what it is, and they kind of see it, but they don't really see it because you can't really see it because it's lit from the top down. If you can light your table from the side, going across at the height of your part, it's much better. You can see everything. What you see with the lighting coming across versus the lighting coming down is 100% better. So, we've been recommending that for several years now, and it's changed a lot of the shops that we work in. So, any other questions?
We're at 3247, so if anything else we could answer for you guys, please feel free to stop by. And we really appreciate you guys coming. Enjoy the show.
Thank you.